Today we're here to talk about fuel quality checks. By that I mean the steps and procedures that we're going to follow to make sure that your customer's fuel is up to standard. Say you've got a customer that's been in a few times with a performance problem, and you've checked the fuel injection system out, perhaps even replaced a few of the components, but the problem still persists. A lot of times this can be traced to poor fuel, fuel that has too much alcohol in it, or perhaps even has water in it. And now, with this approved gas check kit, we have an easy way that we can use to check the quality of the fuel. Remember, when you're performing this fuel quality check, don't smoke or have anything in the area that will ignite the fuel. Also, make sure you do this check before you start replacing parts needlessly. Now let's take a look at some of the components that make up this gas check kit. First, we have this Teflon tube with a steel cable running down the center of it. Now this is used together with this special paste to check for the presence of water in the fuel tank. Next we have this graduate. We're going to use this later on to check for the presence of alcohol in the gasoline. Third, we have these test pads. These are used to check for the presence of lead in the gasoline. And last, we have this pressure tester. Now we're going to use this to measure the read vapor pressure of the fuel. This is a very important aspect of fuel quality. There are four basic elements in this gas check procedure. First, water in the tank test. Second, alcohol detection test. Third, leaded gasoline test. And fourth, the gasoline vapor pressure test. Now let's start with the water in the tank test. We're going to use this paste here to test for the presence of water in the gasoline. The first thing we're going to want to do is push the cable to expose the cable tip from the Teflon tube. Now coat this cable tip with this aqua paste. Don't be afraid to put a lot on because we have to have enough to get a good reading. Once you've got it coated, you want to pull the cable back into the Teflon tube. This will protect it for when you insert it in the filler neck. Once you get that done, you can insert the whole assembly down into the filler neck. Some cars you'll take as much as 6 feet to do this. Now keep pushing it in until you feel like you're at the bottom of the tank, because that's where the water's going to be, water being heavier than gasoline. Once you've got it inserted all the way, you're going to want to push the cable to once again expose the cable tip out of the Teflon tube. Now wiggle or rotate the whole thing around to make sure that the cable tip gets exposed to the bottom of the tank. Okay, once you're sure you got that done, pull the cable tip back into the Teflon tube to protect it when you pull the whole thing out. If there's no water in the fuel tank, the paste will stay the original color. However, if you do have water in the fuel tank, you might as well stop right here before you do any further tests. You'll have to drain the fuel and clean the fuel tank. Water can get into the fuel system several ways. One way is at the filling station during the fill-up itself. Another way is if there's a leak in the fuel tank vent system. If you think you do have a leak in the fuel tank vent system, you'll want to use this slack tube tester to pressurize the system and troubleshoot for a leak. Simply follow the directions that are given in the repair manual microfiche. Now that we've determined that this fuel doesn't contain any water, we can check to see if it contains any alcohol. Now, it's important to realize that this test is not necessarily scientifically accurate. What I mean by that is that while it will tell us whether any alcohol is present in the fuel, it won't tell us whether that is ethanol or methanol. First, we want to pour some of the suspect fuel in this graduated container. And make sure you've cleaned the container from the previous test. Fill the container exactly to the 10 milliliter mark. And once we've got exactly 10 milliliters of fuel in the container, we want to add exactly 2 milliliters of water. You can calibrate this eyedropper to add the water with using this container like we have here. Make sure you add exactly 2 milliliters of water, otherwise the test will be incorrect. Once you've added the water, put the stopper in and shake the container up. You got to shake it for at least a minute. Let the stopper off to release the pressure. Make sure you shake it for at least a minute. And once you've shaken it up, set the container on a level surface and let it stand for at least a minute. Any alcohol that's in the fuel will combine with the water and separate out. After it's settled, we can take a reading from the bottom of the cylinder right here at the boundary between the two liquids. Ours says 3.1. To determine the percent of alcohol in the gasoline, subtract 2 from the reading. That's because we added 2 milliliters of water in the beginning. Now, we subtract 2 from our reading and multiply the remainder by 10. In our case, it works out to be 3.1 minus 2. That gives us 1.1 times 10, and that's going to equal 11%. That means that there's 11% of alcohol in this particular sample of gasoline. Since this test won't differentiate between ethanol and methanol, we're going to want to investigate where our customer purchased their fuel. Now that's important because with our cars, the ethanol content of the fuel should not exceed 10%. However, if it's methanol, it should not exceed 3%. Now another test we're going to want to do is to check whether leaded gasoline has been used or not. Now to do that, we can use these little test pads included in the gas check kit. Now with these pads, it's important that we don't get them contaminated in any way. That could cause an invalid test reading. Now before we perform this lead detection test, we want to get the exhaust warm. Not necessarily hot, but at least warm. So start the car, run it for a few minutes, and then shut it off. Now take a dampened cloth and wipe off the area inside the exhaust where you're going to perform the test. This is to make sure that there's no excess carbon in that area. Once you've got that done, take your pad, your test pad, and moisten it. Now there's a couple things you want to be aware of here. First, you have to use distilled water. And second, you want to make sure your hands aren't dirty because you'll contaminate the pad. Once you've got the pad moistened, place the pad over the area in the exhaust where you're going to conduct the test. You got to hold it there for at least a minute. Once a minute has gone by, you can take the pad out, set it down, and watch for a color change. If there's lead in the exhaust, the pad will change to a reddish brown. If there's no lead in the exhaust, the pad will stay a grayish black. Now let's move on to an interesting and important part of this fuel check procedure, and that's checking the vapor pressure. Fuel that vaporizes too easily can cause a hot starting or a running problem. It's also important to realize that fuel containing alcohol will not come through this test procedure properly. Another important point is the fuel must be chilled before you complete this test procedure. Now to chill the fuel, use the container in the test kit that has a top on it. First take the top off and pour the fuel to be tested in the container. And put the top back on and store the container either in ice or chilled water, something that'll cool the fuel down. And we're going to use this pressure tester here to measure the read vapor pressure of the fuel. In the bottom of this tester is the fuel cup. This is where we put the fuel to be tested. We want to chill this along with the gasoline, so we'll put it in the ice as well. Now the next step is to fill this thermos cup about 3/4 full with hot water. Now we want the water temperature to be about 110 degrees. And we also want to make sure that during the duration of the test, the temperature doesn't fall below 105. Now we'll want to put the remainder of this pressure tester in the hot water, and we're going to want to wait now for a couple minutes and let all our temperatures equalize. Once we have our temperature stabilized, we're going to want to take the fuel cup out and put it in the fuel cup holder. Next, we'll take the top off our container that's holding our chilled fuel and use this dropper to fill the fuel cup till it's about an 1/8 inch full from the top. This will take a couple of times. Now we'll want to take our pressure tester out of the thermos cup and make sure you shake off any excess water from it. Now we can install our fuel cup into the bottom of the pressure tester. Make sure you do this quickly and make sure you hold both elements vertical while you're doing this. Thread the fuel cup in hand tight. Once you get it threaded in, you can put the entire pressure assembly back into the thermos cup. Now the last step is to install the thermometer. Once we have that done, we're going to want to wait a couple minutes and let our temperature stabilize. Once we've let this entire assembly set for a couple minutes to get the temperatures equalized, we're going to want to shake up the entire assembly to help vaporize the fuel inside the tester. Now, before we do that, we're going to want to grab the pressure gauge assembly and try to hold it tight against the top of the thermos cup to help minimize the water loss. And we're going to want to turn the entire assembly upside down so that the gauge is at about a 45-degree angle and shake the entire assembly. Now, once we've done that for a few minutes, put it back upright and take a reading on your pressure gauge. Now, if the needle's fluctuating, tap the gauge to try to get it to settle before you take your reading. It's important that you get a steady reading. And once you've taken your pressure reading, take a look at the thermometer as well, because you have to correlate the temperature along with the pressure when you take your vapor pressure reading in the instruction chart. Now, once we've obtained our vapor pressure from this chart in the instructions, we'll want to compare that with what the vapor pressure limit should be. There's a second chart in the back of the instructions here which gives us those limits. If we have fuel that has vapor pressure that's higher than what those limits should be, this could cause problems such as hot starting or vapor lock. And that completes the gas check procedure. The 4 steps are water in the tank test, alcohol detection test, leaded gasoline test, and the high fuel vapor pressure test. Remember, if you're getting reports of poor drivability or poor performance, don't forget to make your gas check. This might save yourself a lot of time and needless repair work. Many times, drivability or starting problems can be caused by dirty or faulty injectors. Today we're going to talk about the proper servicing and testing procedures for these CIS injectors. Now, it's important to remember whenever you're working on any part of the fuel system or testing injectors, don't smoke or have anything in the area that could ignite fuel or the mineral spirits that we're going to use to test these injectors with. Now, let's get started. Now, this is the tester that we use to test CIS injectors with. Remember, never use gasoline or any kind of solvents in this tester. Only use mineral spirits. Poor injector performance can often be fixed by simply cleaning and flushing the injectors using this tester. The first thing we're going to want to do is check the injector visually for rust. We're going to want to look here at the injector tip as well as the injector inlet. If there's any signs of rust or corrosion, then we're going to want to replace the injector. If the injector's okay, we'll want to install it on the tester. Now, don't tighten this union nut all the way. We'll need it loose in order to bleed the tester. Also, make sure you have a suitable container to catch the injector spray. Next, put on a pair of safety glasses. Never run this test without protecting your eyes. Once we've got our injector hooked up to the tester, we want to turn this pressure valve counterclockwise until it's all the way open. Then we pump the lever a few times, slowly. What we're doing here is bleeding the pressure line and the gauge. Now once we've got them bled, we can tighten the union nut with our wrenches. Once the tester's set up and bled, we're ready to check the injector chatter frequency. And before we do that, we want to make sure this gauge valve here is closed all the way. Closing the valve protects the pressure gauge. Also, the test wouldn't be correct if we did it with the gauge in the circuit. Now we want to pump the lever quickly, about 20 or 30 times. The chatter frequency should stabilize after the tester lever's pumped about 20 or 30 times. It should sound like this when it's stable. If you can't get your chatter to sound like that, you'll have to replace the injector. Now once the injector is making the correct sound, we're ready to perform the spray pattern test, the opening pressure tests, and the leak tests. It's important that you perform all those tests in that sequence to get the proper results. When checking the spray pattern, make sure to leave the gauge valve closed. Then purge the injector by pumping the handle quickly, about 2 strokes every second for 5 or 6 seconds. Then slow down to a rate of about 1 stroke per second. Once we slow down to this rate, the injector should chatter. As soon as we get that chatter sound, check the spray pattern. What we're checking for here is a conical, well-atomized spray, because if the fuel isn't atomizing, it won't burn at a consistent rate. The angle of this spray pattern should be about 35 degrees, just like ours here. If you get a one-sided spray pattern within this conical spray angle, it's okay. If it's spraying a steady stream, that's not atomizing at all, and the injector will have to be replaced. Now, if you've checked out okay up to this point, we're ready now to check our opening pressure. The first thing we'll want to do is open this gauge valve. That's going to allow the pressure from the tester to work on the gauge so we can actually measure the pressure. Then we'll want to operate the tester handle at the rate of about 2 times a second. And what we're going to watch for is where the gauge needle changes direction, right there at the highest point that it gets to. That tells us what our opening pressure is. You'll see with this injector it's about 3.8 to 3.6 bar. Always check the microfiche for the proper specification. To ensure smooth engine operation, try to use injectors that have close to the same opening pressure. Now, if your injectors are out of specs, opening pressure that is, you'll have to replace the injector. But if your injector opening pressure is within specs, now you can do the leak test. Now, the first thing you want to do is wipe off the tip of the injector. Using our previously established opening pressure as a reference, we slowly increase the pressure. Now, a drop may form on the tip of the injector, but if it falls off within 15 seconds, then the injector is considered to be leaking and should be replaced. Now, here's another tip you can use. Some of our later model engines have these new high-pressure injectors. These injectors have a finer thread pitch than the previous style injectors. In order to test these injectors, you'll have to use this adapter, 8034/7, to connect the injectors to the injector tester. Since these injectors have a higher opening pressure, always refer to the microfiche to get the proper specification. Now, as a review, to properly clean and test injectors, first, always use mineral spirits. Check the injector visually for rust. Bleed the pressure line and the tester. Check chatter and spray pattern. Check the opening pressure and perform the leak tests. And remember, always use the special adapter whenever you're checking or cleaning the high pressure injectors.
Hi, Mark. What are you up to?
Hi, Jim. Well, I'm working on this trip computer here. The customer, I guess, complains that the fuel mileage display is a little low. But there's two displays here. I'm not really sure which one is which.
Yeah, there's an instantaneous mileage display, and there's also an average fuel mileage display.
Oh, that's what the other one is.
Yeah, and you know, I found that the owner's manual probably has the best description on what each of those displays is for.
Well, that makes sense. I guess I'll have to read it. You know, I've worked on a couple of these before, and I think I know how to make the mileage calibration adjustment on here. There's a slide switch on the back of the instrument cluster, right?
Right, and it's also important to know when to make the adjustment. You should make the adjustment if the difference between the actual mileage and the mileage on the display is greater than 10%.
10%?
Right. You know, why don't we go through that adjustment procedure, and let's also talk about how you tell whether you have the right control unit in the car.
All right. I read about that procedure the other day. All I have to do is press this reset button here with the ignition off, then turn the ignition on while holding the reset button depressed. The calibration code should now be displayed. There's the backward 6, and then the 3-digit code number. Since different cars have different code numbers, it's important that you check the microfiche to make sure you have the correct one for the car you're working on. Now we can check the country code. By depressing the lower portion of the rocker switch here, a code should be displayed. It displays US, but you got to be careful. A little while ago I had one in here that had CA in it. That doesn't mean it had a control unit in it for California. That means the control unit was meant for Canadian cars, so we had to replace it.
You know, I had to replace one a couple of weeks ago, and when the new one came from parts, it was in a little black bag.
Yeah, I saw that before too. I didn't know what it was, and I asked the DSM, and he told me it's there to prevent the control unit from becoming damaged due to static electricity. He said that you're not supposed to touch the control unit until after you've got it installed in the car.
Now that we know we have the right computer in this car, let's get back to the fuel consumption adjustment.
Okay.
First, let's see where the computer is set.
All right, I think I know how to do that. First, I turn the ignition off, and then I press the reset button on the trip computer switch. Now I turn the ignition back on while holding that reset button down. Once that's done, I press the top part of the rocker switch on the trip computer switch here, and the display should show.
What's the reading?
0. That means it hasn't been touched since it left the factory. According to the microfiche, I can vary the setting from 0 to plus or minus 15%. That means we got plenty of room to adjust this one.
Okay, so we need to figure out how much of an adjustment to make.
Well, the display reads 24 miles to the gallon. The car actually gets 27. Since our adjustments are made in percent, we have to calculate what the actual mileage difference is in percent. To see what percent of 24.3 is, we need to divide the 3 by 24, then multiply the result by 100. The answer is 12.5%. Now I can get at the slide switches. This switch here is set at 0%. Since the adjustments are in increments of 5%, we'll move the switches like this to the 10% reading. This will bring the display as close as we can get to the actual mileage.
Now let's check the setting. Shut off the ignition, then push and hold the reset button. Then turn the ignition on before releasing the reset button. Now push the top of the rocker switch. The display should read 10%. Good, it does. Well, you know, on that car that I replaced the trip computer control unit on, I also had to readjust the miles to empty display.
Yeah, you're right. You not only have to do it then when you replace the trip computer, you also have to do it anytime you replace the fuel tank or the fuel tank sending unit. And I've read in some of the training information that adjustment's in different places on different cars, like on the Coupe GT with the electronic instrument display, it's over here on the side.
Right.
And on 5,000 models with a turbo, they got a little slide switch on the top.
That's right. Let's go through it on this car.
Okay.
Remember, the fuel tank has to be full. With the ignition off, press and hold the reset button. Turn the ignition on, and then release the reset button. The display reads 700. According to the microfiche, the reading for this car should be 750. It's always a good idea to check the microfiche because the readings on some cars vary. Well, I worked on a 4000 the other day, and its setting was 550. So I guess the setting varies with the size of fuel tank in the car.
That's right. The DSM explained that to me. When the trip computer's in the calibration mode, what it's actually displaying is the level of fuel in liters times 10. In other words, a reading of 750 would translate to 75 liters. And with this particular car, even though it has an 80-liter tank, we set it 5 liters below to have a margin of error so the customer doesn't run out of fuel.
Okay. Well, the adjustment on this car is pretty straightforward. All we have to do now is turn the adjustment screw and dial in the correct setting. The screw has a 1/2 turn range. If the reading cannot be brought to about 750, check the fuel gauge operation. If the gauge operates okay, refer to the repair manual microfilm for further troubleshooting procedures. In summary, when working on an Audi trip computer, know your symbols. Use your owner's manual for symbol descriptions. Check the microfiche for the correct control unit code and make sure the correct US version of the trip computer is installed. Only adjust the average fuel consumption when the display deviates by more than 10%. Reset the miles to empty display whenever the fuel sending unit, fuel tank, or trip computer is replaced. And always refer to the repair manual microfilm for the correct settings, specifications, and procedures.